Friends, welcome back to my channel. In this session we will see how we can test TL431. This is a question from my viewer. Is there a way we can test our TL431 using voltmeter? Yes, we can. Let's see. First we will see a very short brief about TL431. TL431, it is a 3-terminal device. It is most commonly used in supplies, switch mode power supplies. It is used as a voltage detector. Its symbol is similar to Zener, but its work is slightly different than the Zener. We can say it is a controlled Zener. This pin is called anode pin. Similar to Zener diode, it is connected to ground, reverse polarity. Same as in Zener, we use a load. I will connect LED, and here is a remote pin. That is reference pin, that is control pin. Function of this pin, when its reference current will reach at specific level, but this time I will just only consider the voltage. When voltage reference between reference pin and anode pin or ground pin, it is 2.5 volt. When this pin number 1 will receive 2.5 volt, at that time it will switch. Very simple method. Before this there will no current. When this will reach at 2.5 volt, it will turn on. We can provide voltage cathode to anode up to 37 volt. From this point to this point we can provide 37 volt as per in data sheet, and we can program it up to 100 milliampere. Cathode current 100 milliampere, minimum 1 milliampere, that is its minimum regulation current. From 1 milliampere to 100 milliampere we can take current. TL431 2.495 volt, we will consider 2.5 volt. When it will receive 2.495 or 2.5 volt, at that time it will allow cathode current. Just only simple formula. For that purpose, a voltage divider network is used to bias this pin. If we are going to send some 10 volt, 12 volt, at that time a voltage divider combination is configured so that when the voltage will reach at that level, this voltage divider network will provide 2.5 volt at this pin. This time I will use 1 kilo ohm resistor. This is just only for demonstration, otherwise we need a proper calculation to use reference current. When we will use proper reference current, at that time we will take proper cathode current, but we are using just only for test purpose. So 1 kilo ohm, 1 kilo ohm. This is a test circuit. We are taking 2.5 volt, that means 1 kilo ohm, this is 1 kilo ohm, total 5 volt here. So it will divide the voltage here by 2. If we are providing 5 volt, at that time it will receive 2.5 volt at pin number 1. At that time it will allow a current to this LED. Let's make this circuit. If you see this TL431, the leftmost pin, that is reference pin, the center pin, that is anode pin, we will connect it to ground. This is output pin, that is cathode pin. I will connect LED, the short lead, the small lead, that is cathode pin. If you see inside the large terminal, that is cathode, we will connect to cathode of this TL431. We will make it in this way. Now we will connect one resistor to pin number 1, the second resistor to pin number 1, that is 1 kilo ohm resistor, and we will place it here, and we will connect 330 ohm resistor here to control the LED current. Because we are using maximum 5 volt, we are connecting 330 ohm resistor here. with 1 kilo ohm. So two resistors are connected here. This resistor, and we will provide the ground to the center pin. Our test circuit is ready now. Now I will apply power, ground to this resistor, and positive here. Ground here, positive here. So these pins are interconnected because this ground is common. Now I applied 1.26 volt between this point and this point, and at reference pin we are taking 639 millivolt because two resistors are dividing voltage by 2. Now I will increase the voltage. When the voltage will reach at 2.5 volt, the LED will start to conduct. The LED will turn on. Why? Because it allowed the current. When we will decrease the voltage at pin number 1, reference pin, when it will less than 2.5 volt, at that time it will not allow to flow any current. For example, if we are providing 37 volt, 36 volt here, until we will provide 2.5 volt at this pin, it will not allow any current. When it will receive 2.5 volt at pin number 1, at that time it will allow current. For how much current we are programming it, it will depend on this resistor, current limit resistor. So we can say when we will receive our required voltage, that time we will measure the voltage between the output terminal and this terminal, because the voltage will drop across the load depending on the load current. Maximum 100 milliampere current it can provide. Now I will check voltage between positive terminal and pin number 3. When we will apply 2.5 volt, at that time it allowed voltage. How much current we are programming, it will drive the load. A simplest word, when we have 2.5 volt at pin number 1, it will allow to turn on the load. We can see this one. Less than 2 volt, there is minor current. That is why we are not using accurate resistor. So this is the simplest way, that when we have 2.5 volt, at that time it will allow to flow the current from this LED. And we can check the voltage drop across pin number 3 and the positive pin. That is 3.4 volt across this load. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.